Our first speaker is Doug Madory, who will be presenting The Scourge of Excessive AS Sets. Doug is the Director of Internet Analysis for Kentik, where he works on Internet Infrastructure Analysis. Prior to Kentik, he was the lead analyst for Oracle's Internet Intelligence team, which was formerly Dyn Research and Renesys. This is Doug's 9th time presenting at NANOG. He first spoke at NANOG in 2010 during a lightning talk session about accidentally importing censorship. Doug?
All right, good morning, everybody. As stated, my name is Doug Madory. I'm from Kentik. This is a talk entitled The Scourge of Excessive AS Sets. This is another collaboration between myself and Job Schneiders. Job is currently in between jobs. If you're looking for a guy who is an expert on routing security, RPKI, or even Nyan Cat art, check out Job, reach out to him. And with that, we'll talk about excessive AS sets. So this is a talk about AS sets, not AS sets. If you came here looking for AS sets, you're in the wrong place because let's talk about AS sets. So in BGP parlance, we have a lot of overloaded terms. AS sets is yet another one. So just to be clear, what we're going to talk about today is the IRR AS set object type. This is a record in the IRR database that defines a group of ASNs, typically used for routing policy, grouping those ASNs together, not the BGP AS set construct, which has been recently deprecated. If you check out RFC 9774, is a recently published finalized RFC that deprecates this. This is, if you work with BGP data at all, you'll find like in the AS path, you see like one or more ASs in little curly braces is the convention, how it's written. That was the mechanism that was, the attempt was to try to consolidate messages where you would have multiple prefixes originated by multiple ASs in the message. The problem is that would break the association between which AS was originating which prefix, and then would break things like RPKI ROV or any other origin-based routing filtering. So BGP sets, BGP AS sets are no more, and that is not what we'll talk about today. If you ask any questions at the end, people will throw things at you. So on with AS sets. IRR AS sets. So I think this is a discussion that's useful in the context of BGP leaks. This is how IRR AS sets are used to try to limit the propagation of leaked routes and limit the disruption. So let's talk about how they might work in a BGP leak. So I take this one example from March 2024 from last year, where Russian mobile provider MTS leaked out about 30,000 routes from hijacks through its transit providers Lumen and a little bit through Aurelion as well. My friends over at Curator were probably the first ones to spit something out about this particular leak. These kind of things happen at least once a week. And then in our discussions, at Kentik we have a lot of NetFlow data. As we have aggregate NetFlow, we can go and look at like how much traffic was potentially misdirected down. Those went through MTS to reach these destinations when it shouldn't have, and that's the graph from our platform on the bottom here. Just looking at by country, we can do by AS destination, but some non-zero amount of traffic was misdirected as a result of this leak. Again, these happen with some regularity. One other thing I'll mention about this leak in particular was we have these phenomenon of prefixes that are regional routes is typically what they're called. They're routes that are limited in propagation intentionally, and so what ends up happening in a leak is that the leaked version then fills in the vacuum where many ASs don't have this route in their table, and so they don't have there's not this natural contention between the proper origin and the leaked version, and so in this graphic here, what's trying to depict here is this bulge. It's a x-axis is time, the y-axis is the percentage of BGP sources that we have, and how many see, in this case, hkicks upstream of Netflix. Well, during this leak, most of the internet thought hkicks was upstream. That's what this is depicting. I'm not sure what was the operational impact in this case on Netflix, but in general, these things can cause problems. They're usually more specific, so the leak does attract traffic. But let's get back to AS sets. So what is it? So an AS set IRR AS set. This is a special database object type. It represents a group of ASNs as well as other AS sets. Primarily used for route filtering, policy control for ISPs, and network operators. The way it works is that you ultimately want to arrive at a prefix allow list. Allow list is my term. It's not an official term here, but this is a prefix whitelist. You'd like to figure out what are the prefixes that you would expect to see across the BGP session, allow those, and anything you get that's not in that list, you would ostensibly reject. The way it would work is in your AS set, you would recursively go through each member and figure out if it's an ASN, then we're looking at the route objects, either route 6, if it's v6, figure out what are the prefixes it would originate. If it's another AS set, then you kind of start the process over and go through its members and so on. And so you keep going until you end up with this very long list, and sometimes excessively long list of prefixes that you've essentially included in this allow list. And then you take that into a configuration you'd apply into a session with your an AS's neighbor to allow a certain number of prefixes through. So there's some big challenges for AS sets. Like many of us, there's no inherent quality, integrity, or authenticity controls over the content. There's no limits to the number of AS members or AS sets that can be included in the AS set. There's no limit in the depth of the resulting recursion. We talked about how this would be recursively resolved, which allows this kind of unlimited and unchecked growth. In fact, if you spend some time digging around in this, you'll find that there's also you'll find an AS set contains an AS set that contains the original AS set, and so you can have these like recursive loops, so there's clearly a lot of mess here. I've noticed in any of the work I've done in the last 15, 16 years in this space, any area of routing phenomenon that could allow unlimited unchecked growth will have unlimited unchecked growth. I refer you to a previous presentation I had done on prepending, excessive prepending. But the other thing is having written this piece with Joe a couple months ago, and then kind of talked at the last NALG with a number of carriers or networks about their challenges with AS sets. Another thing that's bubbled up is just a lack of a common understanding of the different use cases of AS sets and how those may or may not you may not wish to interact or include one in another. So in this case, sometimes these are AS set is to define all the prefixes that may occur in the customer cone. So you're trying to figure out what are all the ASs that would be in the network's customer cone, and you'd like to say only things in my customer cone should I be transiting. Well, that's different than an AS set that defines what are all the settlement-free peers of a network. That might be used for different types of policy control. And then you've got IXP AS sets that are pretty common out there, and those define who are the members of the IXP and what would be potentially the prefixes that would be legitimate, that would be circulated within the IXP. Now, where we get into problems, and we'll see an example of this, is where different types are included as members of other types of AS sets, and then this kind of spirals out of control. So in the italics here at the bottom is kind of a mind bender here of, if you try to read it with me here, if the AS set includes an AS set, includes other AS sets, you very quickly, the original network that created the AS set loses any awareness as to what's included in this AS set that they are now communicating to other networks that they should use to create prefix lists, allow lists for their sessions. And so it becomes unwieldy very quickly and hard to maintain awareness of the contents. So going back to this leak we started with at the beginning of the talk. So we had this March 11th, 2024 routing leak. The AS set for MTU is AS-MTU. If you plug this into bgb.tools, which has a really cool interface for navigating through AS sets and the members and how they expand, you see the AS-MTU expands to 43,823 ASNs. That's a lot, especially given the fact that if you were, the last time I checked and we made this slide, I was seeing about 83,000 ASNs in the global routing table. So more than half of the ASNs in the global routing table are included in the AS set of this network that primarily provides transit into Russia and that part of the world, Eurasia. So that's too many. maybe we can agree on that. And if you were to expand that and turn it into a prefix list, we're talking millions of prefixes, millions of lines that you would be applying to a router config it's all kind of counterproductive. If you look at some of the prefixes that are included in this AS set, I just picked out a handful here. These are things that probably shouldn't be coming through a Russian mobile carrier, like, the U.S. Department of Defense, rural telephone service in Kansas, American Express, AWS, Government of Kenya. There's literally thousands of examples along these lines if you were to dig into it. So we've got an example of an excessive AS set that is whitelisting too many things. If you're not already aware, a tool that is very popular for building these BGP filters is BGP4Q. Got the GitHub link here. And so, if you plug in the way that tool if you use a command line, plug in ASMTU, and count how many lines you're going to get. In this case, we're going to get about 1.3 million lines. This is a lot of lines of router configuration that you're generating from a single AS set and would potentially be applying into a router config. There's a little -A option that'll aggregate adjacent prefixes and to try to reduce the number of lines. That still brings it down to 271,000 lines. This is pretty unwieldy. And then if you look at the number of unique v4 addresses that are described in these prefixes, it's like 1.3 billion out of 3-ish billion prefixes. So we're whitelisting much of the internet. Another caution to be aware of is that when we talk about when AS sets are used and communicated, we should always refer to the source IRR. So the convention is to be like RIPE : ASMTU or something, just to verify what IRR we're talking about, because in this example here of Voxility, this, depending on what IRR source you're using, you can have orders of magnitude in difference between an AS set. In the blog post that Job and I wrote a couple months ago, we used a leak from Voxility to analyze. I kind of didn't use it in this talk because Voxility, as a BGP-based DDoS mitigation provider, it can ostensibly be transiting stuff from varying places around the world. It's maybe less of a good example as an AS set from MTU in Russia. But anyway, so source IRR is very important for AS sets. But getting back to the excessively largeness of this ASMTU, this AS isn't alone, and it's nowhere near the worst. And so I went back. So I asked Ben Cartwright-Cox. I started to do this on my own, and I realized, hey, BGP.tools already kind of did all this, so maybe he already has this on the shelf. And sure enough, I asked him, I was like, hey, could you just make me a list of what are the biggest, AS sets? And he was very kind to do this for me. And sure enough, it's kind of absurd. In this top 10 here, we're looking at AS sets that all are about 102,000. They're very close in size, probably because they all have similar subsequences of embeddings of AS sets that are exploding the size. But again, these are, we only have about 83,000 ASs in the global routing table. These expand to 102,000 ASNs. There's about 2,200 AS sets that expand to over 1,000 ASNs. And, I would argue there's probably very few networks out there that have a legitimate use for an AS set that is that size, as far as like a customer cone that can be expanded to that size, or maybe a peering base that included over 1,000 ASNs. There's really not 2,200 AS sets. I would push back on my own point here in that I can't guarantee you that every one of these is used operationally. In fact, that's kind of a hard thing to know. Some of these, a large number of these may just exist solely in IRR and don't get used operationally, but I know enough from talking to people like at the last NANOG, and since we published the post, that there's enough in the wild that there are operational impacts, and these do get used or communicated for creating allow lists. Right, so like I said, these AS sets have 20 or so thousand more ASs than exist in the global routing table. I brought this, in a conversation again with Ben. I was like, "Hey, can we like trace through like where does this stuff come from?" And so he wrote a little script to trace us back to where are these unrouted ASs coming from, and we'll take a journey here through one of these examples. It may be a little hard to read, but this is an example we chose. This AS set, so right :AS XUA -UA. This is a Ukrainian network. It expands to about 90,000 ASNs, including a lot of unrouted ones. Well, how do the unrouted ones wind up there? Well, we follow this crazy sequence of embeddings, of nestings of AS sets. And if you were to look at this from a geographic standpoint, we're starting with a Ukraine network, traveling to Bulgaria for Balkan IX, the Netherlands NLIX, Russia TTK, China, South Africa, then China again, China Telecom, and then Russia again, Rostelecom, before landing on AS 201.030, the unrouted AS of the Public Corporation for the Organization of Air Traffic in the Russian Federation. I guess they don't need that one. So this is a circuitous path here, but it illustrates the problem that we're encountering, is that there's a lot of this kind of just kind of insane levels of nesting that's going on. And so then going back to an earlier point of talking to people who wrestle with this, and we're citing the fact that there's just not well commonly understood different use cases for the AS sets, and then when they get combined, it becomes kind of explosive, is their little graphics didn't show up here. So I try to put a little box next to each, a colored box, but you'll have to just take my word for it. So there's a mix in this sequence here, in this chain on the right, of ASs that are, I'm guessing, it's not always obvious, are intended for defining a customer cone. There's some that are obviously for an internet exchange, and then you have the customer cone including an internet exchange, but it includes another internet exchange that includes a customer cone. And pretty quickly, once you start mixing those types, then it loses all meaning or usefulness as a source of data that you would use for prefix filters. In fact, if you go down towards the bottom, the bottom half is all kind of transit relationships, although they're not even customer, because like one of these African carriers has got its transit provider included in its customer AS set, and so then it starts a whole another sequence. So I would argue that this mixing of types is also an issue here, and that comes from just a lack of understanding and attention to what people should be including in their AS sets. We probably shouldn't have IXP AS sets included in customer cone AS sets. That's going to then inadvertently create an allow list that allows everything from the exchange to be able to come through when we don't want that. So why is this a problem? In this particular case of this one leak, I can't guarantee that the AS sets contributed to the problem. I don't know exactly how the filtering was constructed for the transit providers involved. There's probably multiple factors, not just AS sets, that go into that process. I would say that it certainly couldn't help, because if you're going to basically essentially create a permit any and have that be your AS set, it's not going to do a lot for filtering. And our only hope with any of these BGP mishaps is automation, right? We can't possibly hope to do this in any kind of manual fashion. And so that's why these IRR-based things are very useful and are used today, and will probably be with us, warts and all, for quite a while. Is that it's the only way you can kind of programmatically create these allow lists to apply to session filters. So, but as I mentioned, some of these really large ones are essentially creating a permit any, but it's worse than that, because there's a cost to it. So each one, when you have one of these AS sets that then expands to 1 million or more prefixes, well, this is an AS set that's going to get updated maybe more than once a day. expanded, applied to a router. So there's just an enormous amount of cost involved to create something that's going to be useless in the end. And for a lot of networks around the internet, this is the reality they deal with. Again, talking to a couple of cloud providers who deal with some of these networks, as well as tier 1 transit providers. They have, again, automation software like many of you probably do, and this may break or does break, depending on the situation, the software that they've got, and they've had to come up with some other way to try to filter through the output of the AS set that they are getting from a customer. So this is causing a lot of work for other people to try to figure out how to clean up some of this IRR pollution. All right, so solutions. On the short term, if your network has an AS set, it might be worth going and looking at who's included in it and what are they including in their AS sets, and see if you can get a handle on how big does your AS set expand, and what does it end up including. I know, again, talking to a couple of networks, they have a couple of these guys have gone out and looked at hey, who is including my AS set in their AS set, and why are they doing that? Because in some of these cases it's inappropriate, and the feedback that has been received sometimes is not that encouraging, where you'd get a network to say, well, A, they have no idea what this is, or the guy who made that left the company 15 years ago and nobody maintains these things anymore. And so there's just a lot of administrative cruft or lack of housekeeping going on in this space, and it's hard to get your AS set removed from someone else's. I mentioned the recursion and the inclusion of different types of AS sets. I understand that in some cases that's necessary. I gave a version of this presentation to a manners workshop a few weeks ago. We had a tier 1 transit provider kind of push back on the recommendation to try to limit recursion in this from that network standpoint. They've got a set of customers. Those customers have got customers, and those customers have got customers. There's no hope that they're going to try to be able to keep track of all the changes on a daily basis of their customer cone. They rely on that recursion to keep their AS set an accurate representation of that customer. Having said that, not everybody's in that boat, as well as within those AS sets are included things like IXPs or peering sets of peers that shouldn't be in a transit list. So this may be an unrealistic thing that we can ever kind of completely perfect. So the longer term solution is going to be new mechanisms that we would use to ultimately retire the IRR-based AS set system, which is going to be with us for a while here. But what we would want to get to is the tools that are being worked on now. So this is in-band BGP signaling. This is RFC 9234. This is like the only to customer attribute that gets passed within a BGP message. This would enable a network or its router to receive a message, understand the relationship of where it was received, and know this is a message that shouldn't be for them, and discard it without having to go check a list of 1 million prefixes and see if it's in there. So that would be an improvement. We've got ASPA. It's in its infancy here, and this is a mechanism where an AS would assert its transit relationships that enables another AS to then check the AS path, look for a value-free violation, and understand this is likely a leak, and therefore reject that announcement. And then finally, things like these signed prefix lists, again, something pretty early on, kind of the flip side of a ROA, where an AS would assert what are the prefixes that it would legitimately originate. But the AS set, IRR-based AS sets, lack a degree of precision and awareness that I think we're seeing it become more and more ineffectual at filtering leaks over time. So this combination of inbound, out-of-bound signaling is what we want to arrive at. That would be our long-term solution for this problem. So at this point, I'd like to thank Ben Cox for his help on the analysis of the AS sets. A few people had some input for this analysis, but from Tony, Aaron, Anise, and lastly from Telia. and I'll take anybody's questions. Oh,
is this one on? Yeah, it's on now. So, Joel Yegley, again. Yeah, one of the things that struck me in you folks doing this analysis was I used to use this facility basically to construct prefix filters for every single one of my peers who had an AS set. And we had some, particularly large ones like Hurricane Electric that are actually like quite well maintained. At least they pass like reasonably looking sanity checks. There's still 200,000 routes.
yeah.
But a whole bunch of these things like have gotten more nonsensical with time. It's like this is a slowly accumulating fiasco. And I have replaced it because of what we were using it for is prefix list filtering with just looking for misorigination and RPKI. So I'm almost to the point where I've completely abandoned prefix list filters for peers, unless it's private interconnect or stuff that's not supposed to appear on the internet. Is that something you're observing in terms of the utility of this?
I think, like I mentioned at the last NowNog, I had a lot of kind of hallway conversations with folks dealing with this, and they kind of arrive at something similar. They're building their own system that at a certain point they're kind of building a separate system that doesn't rely on AS sets anymore. I think you mentioned RPKI ROV. I think I don't know if I said this in the talk. I do a lot of presentations and analysis of RPKI ROV, and ROV is just origin, checking origins, and so there's lots of leaks like the volatility and the MTS leaks. There was nothing misoriginated. So ROV and any kind of origin-based mechanism is not going to help you. We have to understand what are the proper prefixes that we should see across an adjacency or through a session. But I guess I echo your frustration with the system, and I've heard some similar story from a number of other networks in recent weeks as I've been talking about this. So I don't know if there's a hope that we can try to clean this up and make it better, or we at some point soon abandon it and go on to newer technology. Yes, sir.
Hello, Marco Marzetti, PCCW Global. It says not to make any statements, but I want to share what we are doing. We are seeing the same problem. We are a transit provider. What we have decided to do is try to shrink the AS sets, the prefix lists that are generated from the AS sets by listening to the inbound BGP advertisement through BMP. Send everything through a Kafka, analyze everything through what you can call data streams processing, and generate a cache that validates only those prefixes that have been actively advertised by our customers in the last, 1 month, 2 months. It's something that we can fine tune depending on the need.
So you build a prefix list out of the message you normally see through. So you create like a baseline there, and that becomes your AS set or prefix list.
We call it opportunistic prefix lists.
Okay.
And it only includes what has been advertised by the customers, and it's also part of the AS set at the same time.
Okay. Makes sense. So there you go. Someone inventing a solution to this problem.
Yeah, what you're doing, what you have suggested in the long term makes a lot of sense, but it will take probably a decade. And I'm supporting you in the decade, but
we have to have something. Yeah, sure.
Thanks.
Okay. All right. Thanks a lot. Oh, sure.
One more questions. Just if you have a second. Tony Talbert.
What is it, Tony?
Interested in the last questioner's idea seemed reasonable. I'll point out that I think one case you mentioned Voxility as like a DDoS mitigation provider. They have that service, it seems. So that's one of these kind of like different cases that seems to break the model of like, well, it's expected to be this path, but then during an incident, if that's the service they're doing, and there's different ways people do DDoS mitigation, but that's one way that a number of people do it, where they originate a route behind an AS that it's not normally behind. So I would just say beware that approach seems to make a lot of sense, but there may be edge cases that past 1 month window you wouldn't see, right?
Sorry, past 1 month when.
Oh, if the other person was saying they.
Oh, I see.
They
I see.
look at a baseline,
Right.
a 1 month baseline. There may be cases that are considered legitimate that are outside that 1 month baseline. I believe. I'm not an operator of that type of service, so I don't know for sure.
Right. Okay. Thanks. Your point's taken. So just to maybe I can rephrase or summarize your point. It was that so we heard the gentleman from PCW say that they were kind of using learning a baseline from their customers based on them, and so for a BGP-based DDoS mitigation operator, I chose not to get into focus on volatility and the leak in this case because then it gets to get really complicated. But in that case, it could be rare that they announce something, and when it does, you'd like it to work and not be filtered. So that approach might not work for a BGP-based DDoS mitigation provider. Thankfully, there's not that many of those, but I guess if you were their transit provider, you'd have to be aware that that's not going to work for that type of customer.
Yeah. Thanks.
Okay.
Can we get Doug's last slide back up, please? It did a thing. I did.
Yeah.
Pretty place.
Next talk is on excessive air conditioning. Oh my goodness. Wow. Get it? Good. Wow. Thank you so much. All right. Okay.
Fortunately, looks like it was ChatGPT generated or something, but
I hand moved the pixels to make that. I have a lot of free time.
you left enough of the AIDA holes in the background that I could do the counted stitch. And
Wow. That's very kind of you. Thank you.
now I don't do that for everyone, so I'm not saying that all the rest of you should. But as I said, it's Doug's 9th time speaking, so I decided to do a special thing.